We have been learning a lot of exponential functions. We've also been thinking back to linear functions. So we are going to do an assignment called linear, exponential, or neither. And it's going to be an assignment where you can talk about it with your table groups and think through it and help each other. So I just want to remind you of a couple of things that we have discussed. So I'm going to look at the bunnies versus viruses notes real quick. So whenever we did the bunnies versus viruses, we looked at how we increase. So if it is a increase by adding or subtracting, it's called a linear function. And you can write your equation as a y equals mx plus b. So as you're going through this, I want you to refer back to your bunnies versus viruses notes. Then the viruses, they multiplied by 5 every day. So that actually is a constant rate of multiplying by 5 rather than addition or subtraction. So this is an exponential function. It's going to increase rapidly. You can also think about it increasing exponentially. So whenever you write your function rule, you write your start amount times your rate to the x power. So this is your initial amount or start amount, and then that 5 is considered our rate. What is being multiplied by each day, in this case with the viruses. And it's an exponential function. So your variable x is the exponent. And whenever you look at the graph, it is a curve. It curves up and goes really fast compared to a straight line being constant. Whenever we talk about sequences, we're going to do sequences in this as well. Whenever you do sequences, you are only doing the first terms. So whenever you think about the sequence, these are your term numbers. 0 is not a term number. 1 is the first term. 2 is the second term. 3 is the third term, and so on. Same thing with this. These are your term numbers. Terms of a sequence. So you would begin with the first term is 15, second term is 75, third term is 375. So let's look at the assignment that we have for today, the linear, exponential, or neither. Let's see, which one would we want to do? We're going to do this one. They made a mistake in their sequences, so we are not actually going to do that one. So just kind of mark it out. Okay. They put the 0 term in the sequence, but we are not. So this means that this is the first term. So this goes with 2. This is the second term, which would be 4. This is the third term, which would be 8. Do you see what the pattern is?
Yes.
Times 2, right?
Yes.
So what would the fourth term in the sequence be?
16.
16, okay. But then we want to find the initial value or the first term. How do you go backwards? Divide by 2, right? So what is 2 divided by 2? 1. Whenever you write the recursive rule, we write, if you look back, what kind of function is this, by the way? Because we're multiplying by a constant rate of 2. Multiplying. It's exponential.
Oh, yeah.
Exponential. And y, we're going to write multiply by 5. It's multiplying by 2. See, I'm seeing if y'all are paying attention. Good job. Okay, so then the recursive rule, let's look at the exponential. Once we decide it's exponential, we can use the exponential example that we have in our journal, which is the viruses. So the recursive rule, we write our start equals and our next equals now times something for exponential. So this is how we will write our recursive rule. So on this one, whenever I say start, that's our 0 value. So this is the start. So that's the 3. So we do use that 0 value or 0 term. So on this one, we write start equals, what does it equal? 1. Okay, and then we do next equals now. What operation or what's the constant rate? Times 2. Okay, so the next thing is our function. We write that as f of x. Let's look at how we write the function rule. Look back at the viruses notes. So it's over here. Our function rule is written like this. F of x equals 3 times 5 to the x. So that's why I wrote down initial or our start amount times our rate to the x exponent. So let's see. F of x equals, we write our start amount, which is 1, times our rate. Our rate is times 2 to the x power. Could I leave the 1 off?
Yes.
Yeah, so I could just write f of x equals 2 to the power of x. But I would never multiply those. Let's say this is 5, this is 2. Do not multiply 5 times 2 because of the order of operations. Remember, order of operations, parentheses, exponent, then multiply. So whenever you do order of operations, you always do the exponent first. I took that 1 off just because 1 times anything is still just that same number. All right, let's do our graph now. There's no numbers on here, so we have to come up with our own. Let me zoom it in a little bit. So we know this will be 0. We could probably get up to that 4th one. So let's go ahead and do the x-axis up to 4. So 1, 2, 3, 4. And then what is our y-axis going to have to go up to?
16.
16. So what should I go by?
5.
5s, 4s. It doesn't matter to me. 4s? Okay. 4, 8, 12, 16. So 0, 1 would be right around here. 1, 2, 2, 4, 3, 8, and 4, 16. If you were to connect them, which I want you to do, it does have the curve. It almost looks straight just with those first 3. But once you get that 3rd and 4th one, you can really see the curve. All right, so we did number 3. Let's do the next one, number 4. All right, not sure. The only thing we have is this recursive rule. So start at 64, next equals now minus 10. So where does the start value go? At the 0 value, right? Then what do we do from there? Subtract 10. Because it says next equals whatever we have now. So we have 64 now. Subtract 10. Take 10 away from 64, you get 54. Okay, do it again. Minus 10. 44. Minus 10. 34. Minus 10. 24. So what kind of function is this? Okay, why is it linear? Subtract by 10. So add or subtract is linear, multiply is exponential. Okay, let's go ahead and do our sequence. What term do I start with for my sequence? Yep, my first term is 54. My second term is 44. Third term is 34. Then we got 24. What would be the next one? 14. Since it's linear, how is our function going to look? Yeah, we need to do the mx plus b. So what does our m represent? It's the slope or the rate, and our b represents our y-intercept. So what is our rate? What is the m value? Positive or negative 10 though? Negative 10. And what is our b value? 64. So our function for linear would be mx plus b. So f of x equals negative 10x plus 64. Or you could do the opposite. You could do 64 minus 10x. Either way is right. The thing that you just want to make sure, if you have positive 64 on both ones, you have a negative 10 on both of them. Last thing would be to graph it. So we could probably get all four going by 64. So let's see. Let's do 0, 1, 2, 3, 4. What should we go by on the y-axis? Tens? 10, 20, 30, 40, 50, 60, 70. All right, so graph it. So 0, 64, 1, 54, 2, 44, 3, 34, 4, 24. And when we connect it, it should look linear. And it is a decreasing function, as a negative slope. All right, one other thing I want you to fix is number 7. The 0 term should not be on there. So take that off. So this should start with 1, 4, 9, and so on. All right, so with your table group, you're going to work on this. I'll walk around and help you as you need. Okay, this is your assignment to finish. One thing that I want you to look at for number 7, you want to find out if it's linear, exponential, or neither. And if you look at it, there is not a constant pattern. That's like -3 and then -5. So this is neither. And bonus, if you want to find out what the function is and what the rule, what the sequence looks like. Okay, so you definitely want to have neither on there, but bonus would be if you could finish this out. You don't have to graph it, just finish that out. Okay, this is due tomorrow.